Hi guys, so we are going to discuss what is an operating system. So operating system is an interface between a computer user and a computer hardware. It is a software which performs all the basic tasks and acts as a controlled program. So the layers of the system. So makikita nyo dito, itong mga user na to, tayo yan, mga humans. Magko-compile yan dito sa interface. Tapos sa user programs, may system and application programs dito. Pagkatapos nyan, sa user OS interface na organization ng mga operating system. At sa susunod yon, yung mga instructions naman sa mga hardware interface na may disk, tape, and memory. Next. So, these are the following are some of important functions of an operating system. First is the memory management or the main memory. Second is the processor management or the process scheduling or which process gets the processor when and for how much time. Next, device management. It is an operating system manages device communication via their respective drivers. It keeps track of all devices. Program responsible for this task is known as the input or output controller. So next is the file management. A file system is normally organized into directories for easy navigation and usage. And the other important activities such as security, control over system performance, job accounting, error detecting aids, coordination between other servers and users. Next slide is about the types of operating system. So the first type is batch operating system. Batch operating systems, the users of a batch operating systems do not interact with the computer directly. Each user prepares his job on an offline device like punch cards and submits it to the computer operator. Next is the time-sharing operating system. Time-sharing is a technique which enables many people located at various terminals to use a particular computer system at the same time. The third one is distributed operating system. Distributed systems use multiple central processors to serve multiple real-time applications and multiple users. The fourth one is network operating system. It runs on a server and provides the server the capability to manage data, users, group security, applications, and other networking functions. So the primary purpose of the network operating system is to allow share file and printer access among multiple computers in a network. The last type of operating system is real-time operating system. So real-time operating system is defined as a data processing system in which the time interval required to process and respond to inputs is so small that it controls the environment. Next is the properties. So as we can see, here in the properties, inside the operating system, there are three jobs. The job 1, job 2, and job 3. So the OS defines a job which has predefined sequence of commands, programs, and data as a single unit. The OS keeps a single number of jobs in memory and executes them without a manual information. Jobs are processed in order of submission, etc., first come, first served fashion. When a job completes its execution, its memory is released and the output for the job gets copied into an output spool for later printing and processing. So as we can see here, process is basically a program execution. So there's a stack, heap, data, and text. So inside the process, there is a program. So program is a piece of code which may be a single line or millions of lines. So one of the example of program language is C sharp or C++ that programmers in IT world. And next slide, multi-threading. So multi-threading, a thread is a flow of execution through the process code with its own program counter that keeps track of which instruction to execute. Next system registers which hold its current working variables, and a stack of which contains the execution history. So a thread shares with its peer threads few information like code segment, data segment, and open files. When one thread alters a code segment memory item, all the other threads sees that. So a thread is also known a lightweight process. Threads provide a way to improve application performance through parallelism. Threads represent a software approach to improving performance of operating system by reducing the overhead equivalent to a classical process. So these are the diagrams in multi-threading. There's a register, counter, stack. So in the left side, this is a single thread, and the right side is the triple thread, which has first thread, second thread, and third thread. So there are two types of thread. First one is the user level. User level, the thread library contains code for creating and destroying threads, for passing message and data between threads, for scheduling thread execution, and for saving and restoring thread context. Second definition is the application starts with a single thread. So in the user level, the application just starts with a single thread. And in kernel level, it is supported directly by the operating system. And any application can be programmed to be multi-threaded. All of the threads within an application are supported with a single process. Next, the timeline style. So timeline style is the functionality of an operating system which handles or manages primary memory and moves process back and forth between main memory and disk during execution. So inside the timeline style, there's a process address space. So process address space is the set of logical addresses that a process references in its code. So there are three types of addresses, which is symbolic addresses, relative addresses, and physical addresses. So virtual memory. In virtual memory, a computer can address more memory than the amount physically installed on the system. This extra memory is actually called virtual memory, and it is a section of hard disk that's set up to emulate the computer's RAM. The visible advantage of this scheme is that programs can be larger than physical memory. Virtual memory serves two purposes. First, it allows us to extend the use of physical memory by using disk. Second, it allows us to have memory protection because each virtual address is translated to a physical address. So the input or output hardware. As we can see, one of the important jobs of an operating system is to manage various input-output devices including mouse, keyboards, touchpad, disk, displayed adapters, USB devices, bitmap screen, LED, analog to digital converter, on-off switch, network connections, and audio input-output printers, etc. So there are two categories of input-output devices. First is block devices. A block device is one with which the drivers communicate by sending entire blocks of data. For example, hard disk, USB cameras, disk on key, etc. Second is the character devices. A character device is one with which the driver communicates by sending and receiving single characters like bytes, octets, for example, serial ports, parallel ports, sound cards, etc. Next one is the input-output software. So input-output software has two following layers. So user-level libraries, this provides simple interface to the user program to perform input and output. Like kernel level modules. The kernel level modules, this provides device drivers to interact with the device controller and device independent input-output modules used by the device drivers. And the last one is the hardware. This layer includes actual hardware and a hardware controller which interact with the device drivers and makes hardware alive. So next is the file. File, it is named collection of related information that is recorded on secondary storage such as magnetic tapes and optical disks. In general, a file is a sequence of bits, bytes, lines, or records whose meaning is defined by the file's creator and user. So in file system, in its structure should be according to a required format that the operating system can understand. A file has a certain defined structure according to its type. A text file is a sequence of characters organized into lines, and a source file is a sequence of procedures and functions. An object file is a sequence of bytes organized into blocks that are understandable by the machines. So when an operating system defines different file structures, it also contains the code to support these file structures, like Unix and X that support minimum number of file structures. So next is the security. First, we have authentication. Authentication refers to the identifying each user of the system and associating the executing programs with those users. It has username, user card or key, user attribute, fingerprint, iRetina pattern, and signature. Next is the one-time passwords. One-time passwords provide additional security along with normal authentication. So in one-time password, it has random numbers, secret key, network password, and next is the program threats. Operating system process and kernel do not designated tasks as instructed. If a user program made this process do malicious tasks, then it is known as program threats. One of the common examples of program threat is a program installed in a computer which can store and send user credentials via network to some user. So in the following list, there are Trojan horse, trapdoor, logic bomb, virus, yeah. And the last one of the security is system threats. It refers to misuse of system services and network connections to put user in trouble. System threats can be used to launch program threats on a complete network called as program attack system. System threats creates such an environment that operating system resources or user files are misused. So in the following list of the system threats is like worm, port scanning, denials of service, and etc. So that's all for today, all for the discussion of operating system. I hope you learn some about it, and thank you guys for listening.